Hey, Algebra 2 Stirrup here. So we are going to be doing 8G on video, so please make sure you get the homework done for this for Monday. So operations of functions. So domain and range, remember the domain, you're dealing with the x values, so you can't have under a radical, that's going to restrict it, or if you have a denominator, it's going to restrict it. Um, so what are two examples of mathematical operations that have restrictions? So if you had like square root x plus 2, the domain of that would go from -2 hard bracket to infinity. But if I had the same thing like this, notice if I had it as a fraction, watch what my domain does. It becomes a round bracket at the -2. And the reason that takes place is though you can have the square root of 0, that would be in the denominator. So that's kind of a big no-no. Okay, so what are the restrictions on having this? Well, the restrictions under square root of x, this would be just hard bracket 0 to infinity as far as our domain. We couldn't have negative numbers to give us real answers. Um, all right, so the restrictions of this one, x cannot equal 0, so the domain of this first one would go negative infinity to 0, 0 to infinity. This one, x can't equal 3, so our domain would go negative infinity to 3, soft bracket, 3 to infinity. The soft bracket on both the 3's would basically mean that we're not including 3. All right, all real numbers are negative to positive infinity. Greater than 5 is like that. Negative numbers are negative infinity to 0. All numbers greater than or equal to 5, that's the hard bracket. Less than or equal to -4, it's a hard bracket on the -4. All real numbers except for 6, and that's kind of how I did the domain. So the soft brackets at the 6's means we don't include them. Use interval notation to indicate the domain. For all real numbers, oops, didn't mean for that to happen. All real numbers is negative to positive infinity. All non-negative real numbers is soft bracket 0 to infinity. This is kind of a gotcha because non-negative 0 is not doesn't have a sign, so we have to have a soft bracket. All positive real numbers is 0 to infinity as well. Okay, and then all numbers except for 3, so negative infinity to 3, soft bracket 3 to infinity. All right, let f and g be the functions. New function h can be defined by, we can add two functions together, we can subtract them, we can multiply them, and we can divide them. So that's just saying what we're doing with each of those. All right, so if you have 2x and f at x is 2x and g at x is x plus 1, if we were just to add them together, I'm going to go 2x plus x plus 1, which gives me 3x plus 1. And then the domain of this, I can plug anything in I want, negative to positive infinity. Negative to positive infinity would have worked on them both originally like that. And then the second one, if I'm going to go 2x minus, and notice I put this in parentheses for a reason because I'm subtracting it, so make sure you distribute the negative sign. So that's going to give me x minus 1. So again, my domain is that as well. So my domain for each is the same because my two domains above are also unbounded. Now if I was going to multiply them, I'm going to go 2x and then x plus 1. So that's going to give me 2x squared plus 2x. My domain of that one still will be negative to positive infinity. Then if I was dividing them, I'm going to go 2x over x plus 1, and that's really all you have to do there unless things reduce, and they don't reduce here. Now, because I have this in the denominator, that means my restriction is -1. So I'm going to have soft brackets at the -1, so that's what our domain of number 4 would be. So now I have this. Now, remember, x to the 1/4 power is the same thing as the 4th root of x. So that follows the same rules as square root. So negative to positive infinity is the domain of the first, but then square bracket 0 to infinity is the domain of the second. So we have to keep that in mind when we're multiplying them. So if I get 3x times x to the 4th, I can make that to the 4/4, so that's the same as the first. So that becomes 3x to the 5/4 power. Now, we still have that root in there, so my domain of this one is going to go from 0 to infinity. You have to keep your restrictions tight, okay? Second one, when I divide the two, I have 3x over x to the 1/4, okay? So that's as far as I can go with this. Yes, I could reduce it. I could make that 4/4, and then it comes out to 3x to the 3/4 power. But remember, we had this. So that was restricted to this, but because I have a denominator, it's now going to have a rounded bracket at the 0 because that fell downstairs. And there's our answer for that one. Okay, so take a look at the homework that you have. It will be on 8G, and I bet you if you took care of the odds, we would be able to satisfy that one really nicely. All right, have a great day, everybody. See you in class. Bye-bye.